Edge of Reality: 8 Unbelievable Cosmic Anomalies. Welcome to the Edge of Reality, the place where science fiction shakes hands with hard physics, the twilight zone of the cosmos. Buckle up, because what you're about to hear is not fiction. It's the universe, unfiltered and unapologetically weird. Let's begin with the Boötes Void, a region of space so empty, so devoid of matter, it might as well be the universe's ultimate no man's land. Stretching over 300 million light-years across, it's not just a gap between galaxies. It's a yawning cosmic silence, like a place where the universe forgot to build. We're talking about a region with 10% of the average galaxy density. If you traveled through it at the speed of light, it would still take you 300 million years to find a decent star. Scientists don't know if it's a result of primordial fluctuations or some hidden exotic physics. But whatever it is, it's not just empty space. It's an abyss, and it laughs in the face of everything we think we know about the uniformity of the cosmos. Now swing your telescope toward Quasars, those luminous monsters lurking at the edge of the visible universe. They shine brighter than 1 trillion stars, powered by nothing more than matter falling into a black hole. But not just any black hole, a supermassive one. And here's the kicker: some of these quasars existed just a few 100 million years after the Big Bang. How did these beasts grow so fast, so early? It's like finding a fully grown T-Rex still fresh from the egg. We don't know how they did it, but they did. And they're still out there, whispering secrets from the dawn of time. Then there's dark flow, a mysterious, one-directional motion of galaxy clusters that seems to defy the expansion of the universe itself. Picture galaxies racing off in the same direction, like cosmic marathoners drawn towards some unseen finish line. What are they chasing? Or better yet, what's pulling them? Some speculate it's a signal from a parallel universe, leaking through the seams of space-time. If true, it would mean that our universe isn't the only one. It's just one bubble in a vast, multiversal ocean. And dark flow, that might be the rippling current between them. Speaking of things that shouldn't exist, enter the realm of negative mass. Yes, negative mass. Imagine pushing something and it accelerates towards you. That's not a thought experiment. That's a mathematical solution to Einstein's field equations. It flips Newton's laws inside out. In theory, if negative mass existed, it could create exotic phenomena like warp drives or stable wormholes. So far, we haven't found any, but theoretical physicists keep poking at the math, because sometimes the universe doesn't just bend the rules, it rewrites them in invisible ink. And what about fast radio bursts? Those millisecond-long blips of radio waves from galaxies billions of light-years away. At first, we thought they were anomalies, glitches in our detectors, but they kept happening. Random, powerful, and totally unexplained. Some repeat, some don't, some follow a pattern. Others appear to be completely chaotic. We've ruled out cell towers and satellites. What remains is one of the most confounding mysteries in astronomy. Are they from magnetars, collapsing neutron stars? Or are we eavesdropping on an alien civilization, pinging us from across the void? Now brace yourself for the galaxy without dark matter. That's like discovering a car engine that runs without gasoline. Scientists found this galaxy, NGC 1052-DF2, that behaves as if dark matter, that invisible scaffolding believed to hold galaxies together, simply doesn't exist. Its stars orbit so slowly, there's no need for dark matter to explain their motion. Could this be a fluke? or a hint that our theories of gravity and matter are still missing a crucial piece. Whatever it is, it challenges the very foundation of modern cosmology. Let's dive into something wilder. The cold spot in the cosmic microwave background, a huge, anomalously cool region of the sky. Some scientists believe it might be the imprint of a massive void. Others suspect it's a leftover fingerprint from a collision between universes in the early moments after the Big Bang. A cosmic bruise, if you will, where our universe bumped into another bubble universe in the multiverse foam. That's right, this anomaly could be physical evidence that we are not alone, not just in space, but in realities. And finally, we arrive at the most mind-bending anomaly of them all: quantum entanglement. Two particles, separated by billions of miles, influence one another instantly. No signal, no delay. Einstein called it spooky action at a distance because it violates everything we understand about locality and causality. And yet, it's real, proven, verified, used in experiments again and again. It tells us that the universe is not a collection of isolated objects, but a deeply interconnected whole. Reality, it turns out, might be woven from invisible threads of quantum code, entangled, enmeshed, and fundamentally indivisible. So what do all these anomalies mean? Maybe the universe isn't just stranger than we imagine, it's stranger than we can imagine. These oddities aren't just footnotes in textbooks, they're signposts, clues, invitations to keep asking questions. Because every time the cosmos shows us something impossible, it's really just showing us the next step in discovering what's possible. Somewhere in the void between galaxies, there exists a place called El Gordo, a galactic collision so massive, so energetic, that it practically shatters the boundaries of what gravitational physics says is possible. Two gigantic clusters smashing into each other at breakneck speeds, producing a combined mass greater than theoretical models can comfortably explain. This isn't just a clash of stars, it's a full-blown cosmic demolition derby, and yet the physics doesn't add up. Simulations suggest such a high-speed impact shouldn't have happened in the lifetime of the universe. But El Gordo is there, real, radiating X-rays and warping space like some celestial behemoth. The only question is, how? Now pivot to something more intimate, yet no less bizarre. Rogue planets, homeless wanderers, ejected from their parent systems, drifting silently through interstellar space. No sun, no orbit, no day or night, just eternal blackness. And yet some of these loners are as massive as Jupiter, possibly even surrounded by moons or faint rings, carrying the memory of a system they once belonged to. How many are out there? Trillions, perhaps. The galaxy might be more full of planet orphans than stars, a silent majority that defies everything we thought we knew about planetary formation. But not all anomalies are about size. Some are about rhythm. Enter the Tabby star Enigma, a sun-like star dimming and flickering in a way no planet dust cloud or asteroid field can explain. Its brightness drops irregularly, sometimes by 22%, which is staggering. Stars don't just do that. Natural explanations range from swarms of comets to planetary debris, but the mystery remains. It even spawned hypotheses involving megastructures like Dyson spheres, built by alien civilizations harvesting stellar energy. Is it far-fetched? Sure, but in the absence of solid answers, even the wildest ideas remain on the table. Then there's the curious case of ultra-diffuse galaxies. These ghostly structures are the phantoms of the universe, so faint you could stare right through them. Some are as big as the Milky Way, but contain only a fraction of the stars. Others seem to be made entirely of dark matter, while a few appear to be almost entirely free of it. Like celestial jellyfish drifting in the galactic deep sea, they refuse to fit into existing categories. Where did they come from? Did they form normally and get stripped of their stars, or are they relics of some forgotten epoch? Now let's flip the scale again to Planck units, a realm so fundamental that space, time, and even logic start to unravel. Below the Planck length, our entire concept of distance ceases to have meaning. Below the Planck time, causality becomes a suggestion rather than a law. You can't observe, measure, or interact with anything on these scales because the tools we have and the universe itself might not operate down there at all. It's the ultimate do not enter sign of reality, guarding the secrets of quantum gravity with a shrug and a smirk. And just when you think it couldn't get weirder, you learn about white holes. The theoretical opposites of black holes, they don't suck matter in, they spit it out. Permanently sealed from the inside, they reject anything that tries to cross their boundaries. A white hole could be the other end of a black hole's tunnel, creating a cosmic recycling system that spans both space and time. We've never observed one, but their existence is mathematically permissible. Some theories even suggest that the Big Bang itself might have been a white hole event, an explosion, not from nothing, but from something else entirely. Let's not forget axions, hypothetical particles so light, so ghostly, that trillions could pass through you every second without ever leaving a trace. They might solve the mystery of dark matter. They might explain why our universe prefers matter over antimatter, and they might be lurking in the background of existence, shaping galaxies while hiding in plain sight. Finding them would revolutionize physics overnight. Not finding them might mean our theories are still embarrassingly incomplete. Finally, look toward the most volatile, unpredictable stars in the cosmos, magnetars. Born from the death throes of massive stars, these ultra-dense neutron stars wield magnetic fields a quadrillion times stronger than Earth's. A magnetar's surface is a nightmare, solid iron crust, cracking under magnetic tension, unleashing gamma-ray flares that can fry satellites and ripple through space-time. One such burst, in 2004, originated 50,000 light-years away, and it still disrupted Earth's upper atmosphere. If one of these monsters went off in our stellar neighborhood, it could sterilize a planet in seconds, yet they remain brief, furious, and utterly alien.